Okay, now we're going to solve some simultaneous linear equations to find a delta gamma vega neutral portfolio. So this is where I am. Just finished a little bit of maths, which we're going to use in the last video, but not in this video. We're not going to use the Taylor expansion. We're going to use the solving of simultaneous linear equations, right? So what do we mean by delta gamma vega neutrality? Well, if you're a market maker, remember you're buying and selling options and making the market liquid. When the market closes overnight, they have to make sure they've got pretty balanced books so that they don't come back the next day and they've made a huge loss on some of these options that they've sold. So what they try to do is to make sure that the net position Greeks are all near zero. Not necessarily, you have to have lots of options to have a delta gamma vega neutral position. So they're not going to do it option by option. They're going to find the net position Greek for the entire book, and then they're going to buy and sell other options to make sure that they've got a whole portfolio that is not going to be changing very much in price when the underlying changes or the volatility changes. Now, gamma neutral and vega neutral positions are achieved by buying and selling other options on the same underlying, as I just said. But then there's a final stage, which is you need to also take a different position, adjust your position, you've already got one, in the underlying. And in particular, if your net position delta after you've added the other options to make it gamma neutral and vega neutral, so take everything together, then find the net position delta. And if it's negative, you're going to have to buy the underlying. And if it's positive, you're going to have to sell the underlying. So if your net position delta is negative, buy. If it's positive, sell. So what is delta hedging anyway? It's hedging an option with the underlying. Well, a delta hedge is designed to match each unit that you've got the option with delta units of the underlying, because delta is, after all, the option sensitivity to one unit change. So, for instance, if I've got a long position on a portfolio of put stock options, and so it's going to have a negative delta because it's a put and I'm long. Of course, if it's a put and I'm short, it would have a positive delta because of that omega, right? But it's a long position, so the omega is 1, and my position delta is going to be negative, and say it's minus 20. So if I've got a negative position delta of that, I must buy 20 shares. More generally, if I've got a portfolio of long or short positions, you need to buy or sell delta units of the underlying according as delta's negative or positive. I've already said that. Okay. And when you do that, you've got something called a delta hedge portfolio, and it's called delta neutral because the portfolio value will remain approximately unchanged as long as there's only small changes in the underlying price. Because delta is like a linear approximation, it's only good for very small local areas. You might need to have a delta gamma hedge. That gives you a quadratic approximation, which is going to be more accurate for larger changes in the underlying price. But we only really do that for options with big gamma, in other words, options that are very close to expiry. When the gamma starts to get big, we might add a gamma hedge as well. Anyway, let's just go through the way that a delta hedge works. Suppose I've got a short position, just to make things easier, on an at-the-money call option, and it's to buy 10 shares. So it's short, so I've got -1, 10 shares, only one option, so that's fine, it's still 10. And it's at the money, so its delta is 0.5. So position delta is -5. So with the delta hedge, I have to buy 5 shares. And so I've got a portfolio with a call option, which is to buy 10 shares, and 5 shares. Okay, well, how does it work? Suppose the share price is $100 and the at the money option to buy 10 shares is going to be about 10% of 900 of 1,000, isn't it? Because at the money call options are about 10% of the underlying, and the option is to buy 10 shares, so that value is 1,000. So you'd think, okay, well, the at the money call option probably have a price about 100. But just to make the numbers a little bit more distinct, I decided to say that the call option costs $90, all right? So it's not quite exactly at the money. Well, I mean, it depends on the maturity as well, of course. So the delta hedge portfolio's got a long position in 5 shares. And the value of that is $500. And it's got a short position with value, well, it's short, so it's minus 90. So the value of the delta hedge portfolio is 500 for the long position in 5 shares, minus 90, so that's 410. And now I'm going to see what happens if the share price changes by a very small amount. So original value of the delta hedge portfolio is 410. Now suppose the share price increases, I'm saying $2, again, just to make the numbers a little bit more distinguished. Could be $1. It can't be a big increase, okay? So then, well, what should the call price increase by? Well, according to the delta, it should increase by about $10. Each of the options should increase by $1, and there are 10 shares for the option. So that's $10. So now we've got a long position in 5 shares, but they've got value 102 times 5, so that's 110. And a short position in the call option, which now has value of 100 minus 100. So that's total of 510 minus 100, which is still around 410. So if the share price were to fall by $3, the value of 5 shares becomes 485, and the call option price should also fall, this time by about 15. And again, you can see doing similar calculations that as long as it doesn't change by too much, obviously it's only an approximation. It should increase by $10 if there's a $2 increase in price, and it should increase by $15, but actually it doesn't. That's just an approximation for how much the delta is, an approximation for the option price increase. Now, the delta changes whenever the underlying price changes. It can go from 0 to 1 for a call, or from minus 1 to 0 for a put. And it also changes with volatility as well. And if you can't continuously delta hedge every time the underlying price changes or the volatility changes, so that it's always delta neutral, then that's when you've got to start thinking about putting on a gamma and vega hedge. And gamma is greatest for at the money near-term options, and vega is greatest for at the money long-term options. So you don't necessarily want to at the options level, but at the book level, when you look at your entire positions over lots and lots of options, you'll have some long-term ones with big vega, and you'll have some short-term ones with big gamma. And so overall, you could have quite a large position vega and position gamma. So before you do that delta hedging that I just illustrated, make the net position gamma and vega both 0 by buying or selling other options. And that's when I said earlier, they mustn't be of the same maturity. So here's an example. Suppose you're short 50 call options on a stock. Option 1 is a call delta is 0.6, gamma is 0.2, vega is 0.16. Very large gamma, actually. Extremely short-term options. Lots of volatility as well. Two other options on the same stock are available. There's call with delta equals 0.2, gamma equals 0.1, and vega equals 0.1, and put with delta equals minus 0.8, gamma equals 0.3, and vega equals 0.2. And each option is for 10 shares, as we had before. How many of options 2 and 3 should I buy or sell to make the position gamma vega neutral? And then how many underlying shares of the stock should I buy or sell so that the total position is delta gamma vega neutral? That's the question. So first of all, we're doing the gamma vega neutral bit. And it helps to set up a sort of table here. So you can put columns for the number of shares. They don't have to be the same for all the options. What your position is, and you know it for option 1, but what you don't know is what your position should be in option 2 and 3. That's the question. What should your positions be? So let's call them X and Y. But we can still use the delta, gamma, and vega to write down the position, vegas, gammas, and deltas in terms of X, in terms of the position. So for the first one, you've got delta is 0.6, gamma is 0.2, vega is 0.16, and you've got the position delta, you've sold 50 of them, yes, short 50. So the position is minus 50. And the position delta is minus 50 times the delta, which is 0.6, times 10 as well. That's using our position Greek formula. And for the gamma, we've got minus 50 times the gamma times 10. And that is minus 100, and so on and so on. And for the position delta of option 2, we've got delta is 0.2, but you've got the option is for 10 shares. So for the N is 10, and so the delta is 2 times the number of options. Okay, just so that you clear what I'm talking about here. There's N. N is the number of options times the number of units in the underlying per option. I'm using this formula the whole time, okay? So I need not only, how many units is the option for, how many shares is the option for, but also the number of options, which in this case we don't know. That's what we are looking for to solve. That's our X here. And so those formulae minus omega times N times the delta or the gamma or the vega give us these numbers here. Now we can find X and Y so that both the position gamma and the position vega are 0. Remember the net position, we add them all up. So we've got minus 100 plus X plus 3Y. That needs to be 0. And also minus 80 plus X plus 2Y. That's supposed to be 0 as well. And those are two simultaneous equations and two unknowns. That's the net position gap. We can write it like this. And you can solve it the old-fashioned way in this case. But if you've got more Greeks for hedging, or you're doing it in blocks, so you've got several gammas and several different vegas, you wouldn't be able to do the normal way. But I mean, it's easy to see the solution here. You just take one equation from the other and it gives you immediately y equals 20, and then substitute that in the second equation, it gives you x is 40. But you can also do it this way, which is how I do it on the spreadsheet using the inverse matrix. So that's the first part. So now we've got 40 and 20, so long 40 and long 20 on option 2 and 3. And we were originally short 50 of option 1. So now what is the net delta for the portfolio? We know that X is 40 and Y is 50, no, Y is 20. So the position delta is minus 30 plus 2 times 40, which is 80, minus 8 times 20, which is minus 160. And that is minus 380. So we must buy 380 shares to make the portfolio delta gamma neutral. And finally, let's go through the Excel spreadsheet that does this. Yeah. There's the delta gamma vega hedge. So you can change these numbers here. These are just the input. So let's make the gamma a lot smaller, shall we? And 0.4. No, that's too big for gamma. 0.4. 5. That's quite a big gamma. Okay. So the vega should be pretty small for this one, but it could be larger for the others. I'm just playing around here. Okay. And so we can change all of those. Let me just go back to the original numbers so you can see. Oops. Here. And we have this position we can change to, for example, make it plus 50 instead of minus 50. So everything blue is, this is what we're solving for here. Okay, so that's really the important bit. Let me just highlight, that's what we're watching. What's about this gamma vega matrix? Well, that's giving you the net position gamma for the two options. Yeah, and here, because that's the A matrix that we need to invert. And then the gamma vega vector, that gives you the position gamma and the position vega that we're trying to find. And so if I make it I already solved for this one, but if I make it say 80 here, or 2, you see that you're always going to end up with different results. I mean, in this case, if you've got long 2 of the first option, then you should be short minus 1.6 and minus 0.8 of this. But you know, you can't buy 0.1 of an option. So there is some what we call position risk. Sometimes when you solve these, you can't do it exactly. So I've got these rounded results here because for some things you put in, for example, let's put in 76 here. All right, so you've got minus 60.8. So the closest you should do is to sell 60 options. And here, and this should be, sorry, here. There we are. And that change, and blue. So whatever the position you put in here will be the same as the position here, but you'll find that because you have to round, in this case you'd sell 43 and you'd sell 22 here, you're not going to get exactly 0 for your net position gamma and vega. Okay, so that's it for now, and one more video to go.